Welcome back. This section is about quality of instruments in the quantitative paradigm. So we know that when we're researching things quantitatively, we often use surveys, questionnaires, which may be closed-ended or open-ended, scales, such as Likert scales, semantic differential scales, visual analog scales, and Q methodology. And then there are all the instruments such as blood pressure, cuffs, physical scales, stadiometers for height, pulmonary function testing, lab results, etc., etc. Likert scales are probably the most common scales that you see. A number of concepts are measured in the quantitative realm through Likert scales. Most typical measures in nursing research are Likert scales. So an instrument is only as good as its quality, and a study is only as good as the instrument quality. So we're going to talk more about these things. Remember that the higher level of measurement you can do, as far as the most precise you can be in measurement of something, the more sophisticated statistics you can do. So it's better to always have a higher level of measurement. Now, so for example, it's better to have ratio data than it is to have lower level data like interval data. Now, when it comes to Likert scales, technically Likert scales are ordinal because the differences between the categories or levels are not consistent. However, in research, it is acceptable to treat Likert scales as interval or ratio level data for the purposes of data analysis. Now let's look at reliability of an instrument. Now remember, reliability is how consistently an instrument measures something. It's not about whether or not it's the appropriate instrument to measure the concept. So reliability consists of three parts: the idea of stability, or how stable it is over time, and homogeneity or internal consistency, and we'll come back to that, and also equivalence. So stability is often determined by looking at alternative or parallel forms of a test and comparing participants' responses on the instrument they want to use with an alternative or parallel form. So for example, you're comparing your short form of a survey with a longer version of it. Comparing a sphygmomanometer blood pressure with a Dynamap blood pressure. Test-retest reliability is if you imagine someone getting on a scale 3 times, a stable scale, a reliable scale, the weight should be the exact same if you get on 3 times in a row. It shouldn't vary by a pound or 2 every time you step on it. Internal consistency or homogeneity is really about analyzing the items for, remember there's that word homogeneous, right? So how similar all of the items on the Likert scale are to the scale. Okay, so how well the Likert scale items measure the concept, I guess, is the best way to say it without getting too confusing into the validity side. So how that's determined is a number of ways. You'll sometimes, I don't have it on the slide here, but you'll see sometimes a Cooter-Richardson. And that's mentioned on the next slide, so I'll come back to that. But really, this is all very sophisticated testing that gets done with computers. But if you think about how any one item on a Likert scale correlates with the others, so people who score high on one item should score high on all of the items on the questionnaire if the questionnaire is measuring one concept. The scores on the first half of the questionnaire should be similar to the scores on the second half, again, if one concept is being measured consistently. And a Cronbach's alpha is correlating, again, one to all of the others. Equivalence, again, relates back to alternative and parallel forms. The idea of, is it an equal measure of the concept compared to something else? You often look at equivalence because you say, for example, you do want to use a shorter version of an instrument. So these two are very interrelated. Inter-rater reliability if you have more than one person collecting data, especially in a study where you're observing a behavior and maybe giving a checklist for certain behaviors, you would make sure that all of your researchers are consistently agreeing on that. If there's any sort of a scale, like we used at the midterm, where people had to look at a scale of how participants' balance was, so you would train all the researchers to consistently measure the balance, the ability of the participants, their balance, so that you're all consistently doing so. You don't want one person being more generous or more stringent in the administration of the item. So, internal consistency, here's a quick review. How well the items on the scale reflect the total concept. Are they correlational or complementary? In other words, you're looking for a unidimensional scale, a scale that measures one thing and only that one thing. And those are the 4 methods. The Cronbach's alpha being the most common, you've seen that in many of your studies. Coulter-Richardson coefficient is important to note because it's used in a scale that measures dichotomous responses. So instead of a Likert scale where you have 5 choices, this is mostly true, somewhat true, neutral, not true, and very much not true, or whatever. I'm not saying that too well today. Coulter-Richardson is a yes/no, right? So you might ask a question like, I feel hopeless, true or false? I am, I am sad most of the time, true or false. So you're just asking the participant for a yes, no, or two choices. So you'll see, for reliability, you'll see a Coulter-Richardson in that case. Now, data analysis, we know, is partly descriptive statistics of all the demographic variables where you are assessing means, medians, modes, as whatever the case may be, and you are also providing standard deviations, interquartile ranges, etc., depending on what you need to do. And we're not going to review much of that because it's you have some tapes of that already, and also there's not much of that on the exam. Inferential statistics, remember, I have here, this is more of a slide for 4th year. You have to sort of figure out which statistics are appropriate. These are the tables that I showed you in class. I think it's worth reviewing the idea of a t-test, which again is testing for differences between 2 groups on some specific variable, right? So you use a student's t-test. You need to have at least nominal level data for the at least, so nominal or higher, right? This doesn't mean only nominal, it means the minimum level. And the dependent variable would be higher level data such as interval or ratio. Excuse me, sorry, I'm in the way there. The ANOVA is another one we mentioned. It's looking at a difference between groups. Actually, generally it's 2, 3 or more groups, or there's more than one independent variable. So you're manipulating more than one thing. So what it's doing is it's actually looking for cross variances, a bit more complex. And a Pearson's R we talked about as being a correlational statistic that you'll see in those kind of studies that's looking to test the existence of a relationship between 2 variables. And we talked about they must be at least interval or ratio level variables, and correlations go from -1 to 1, with -1 being a perfect negative correlation. As one variable goes down, the other goes up. A +1 would be a perfect positive correlation. As one variable goes up, the other variable goes up. Or as one drops, the other drops. They correlate together. The non-parametric tests that some of you have been reporting out to me and that you're seeing are things like the Mann-Whitney U and the chi-squared, quite commonly used, looking for differences between 2 groups on some element, either in proportions of the variable or ranks of scores. So same idea, you're still looking for differences. It's still probably a quasi or a true experiment, but what you're doing is you have lower level data, so you have to use lower level statistics, but you are still looking for differences between the groups. Kruskal-Wallis is 3 or more groups. I don't think we did much of the other stuff, so I won't get into that. Sometimes you do see what they call multivariate statistical analysis, and this is a bit of a complex slide, but I'll just touch on the ones I talked about in the past. The idea here is, with all of this stuff, that you have several variables in the soup all at the same time, right? And what you're trying to do is predict what the dependent variable will be. So correlational regression, you have two or more independent variables and one dependent variable, and you're just trying to see how the two, it's often way more than two, how they interact together to predict the dependent variable. So for example, you know, which factors will determine the likelihood of condom use? And it would be gender plus age plus years of sexual experience plus, I don't know, something else, ethnicity, right? And if all those four factors together can predict the likelihood of condom use. The other one I talked about a little bit is, I don't think we got into too much into these methods, but I talked a bit about logistic regression, because logistic regression is testing a relationship between two or more independent variables and one dependent variable when the dependent variable is dichotomous, i.e. the outcome variable is yes or no, or positive or negative, or they did or did not do the behavior. And then you determine the odds ratio of that behavior occurring. That's pretty much the statistics at the level I would want you to understand it. I'm going to back up a bit. I don't know if we talked much about validity here. The validity of our studies, remember, validity comes back to the idea of is it the appropriate instrument to measure the concept, not how well does the instrument do its job. So we discussed a little bit of validity, face validity being just kind of a quick overview, construct validity being more experts in the field, ranking each item on your Likert scale and determining if it should stay or go. There are other complicated validity calculations, such as the contrasted groups approach, or divergent validity, where you if you have somebody that you expect to score high on something, on a test on Likert scale, you would also talk to people who you would expect would score low. That way, again, if you know that a certain group of people would be expected to score low, and they do, that shows that your item is valid. I don't want to say too much more about that, but probably worth just taking another quick peek at the similar chart related to validity in your book. Sorry about that, I left it out, but you can do that. Okay, that's the end of this recording. I'm going to say goodbye for now, and I will come back with a qualitative quality recording.